Good evening, all of you. Siddhi Nakashi here. Today we are going to solve some MCQs based on the basics of organic chemistry. So let's start with the MCQs. So our first question is, which of the following is true about the trans-esterification? Now, we all know that. First, we will see the reaction of trans-esterification. So, one ester with alcohol, if we react both, what will happen? This alkyl group gets replaced with this and we will get the new ester. Okay, so what happened over here? Exchanging of the organic alkyl group of the ester with the organic alkyl group of the alcohol. So which option is this? The first option is saying exchanging the organic alkyl group of an alcohol with the organic group of an alkyl of an ester. No, because here is exchanging in between R1 and R2. Second, exchanging the organic alkyl group of an ester with the organic alkyl of an ether. No, because there is no ether. Exchanging the organic alkyl group of an ester with the organic group of an alcohol. So this option is correct. Okay. And the last option is exchanging the organic alkyl group of an ester with the organic group of an alkane. We have not added alkane because in trans-esterification, what happens? Exchanging the organic alkyl group of the ester with the organic alkyl group of an alcohol. So the answer is option C. Okay. Next question. Why do we boil the extract with concentrated HNO3 in Lassaigne's test for halogen? Now, first we have to remember that Lassaigne's test is for the determination of nitrogen, sulfur, and halogen. Okay, and in this test, what we do, we take one fusion tube. In that, sodium metal add करते उसके अंदर and a compound. So what will happen at the end? We will get the sodium sulfate as well as the sodium cyanide. Okay, and to decompose this, we are adding HNO3, concentrated HNO3. Okay, so the answer is for the decomposition of sodium sulfide and sodium cyanide is formed. Okay, so the answer is option D. Next question. All statements are correct for SN1 reaction except. So here we have to find out the incorrect statement. Okay. Now what is SN1? SN, it stands for nucleophilic substitution reaction. Okay. 1 stands for unimolecular because the rate of reaction is only depend on the substrate. Okay, in this, the substrate is alkyl halide. Okay, so first option, it follows first order kinetic. This option is correct. This statement is correct because as I said, the rate is only depend on the substrate. It means it is first order. So this statement is true. Second, rearrangement is possible. Now, SN1 reaction is a two-step reaction. In step 1, what happens? Formation of carbocation, right? And in step 2, attack of nucleophile on the carbocation which is formed in step 1. So because of this carbocation, rearrangement is possible. Okay, to stabilize the carbocation by two methods, either by hydride shift or by methyl shift. Okay, so this statement is also correct. Third statement is inversion of configuration takes place. Now you have to remember this. In case of SN1 reaction, inversion and retention, mixture of inversion plus retention. Okay, so this option is false. Next is two-step reaction. As I already said, SN1 is a two-step reaction. In step 1, formation of carbocation, and in step 2, attack of nucleophile on carbocation which is formed in step 1. So the incorrect statement is option C, inversion of configuration takes place. Okay. Next question. The first organic compound was synthesized in laboratory by whom? Now you have to remember that the first organic compound which was synthesized is urea. Okay, and the preparation of this urea from the ammonium cyanide, from ammonium cyanide is by German scientist, that is Friedrich Wöhler. Okay, so urea is isolated from urine in 1773, and the preparation of urine from ammonium cyanide by Friedrich Wöhler in 1883. You have to remember all these things. Okay, so the answer is Wöhler, option A, Wöhler. Okay. Next question. Which of the following does not come under the organic addition reaction? Now, what is halogenation? Halogenation is addition of halogen. This is halogenation. Hydrohalogenation is what? Hydrogen plus halogen. Addition of hydrogen plus halogen. Hydration is what? Addition of water molecule. Okay. And dehydration is what? D is for removal of water molecule. Okay. Removal of water molecule. Now they are asking which one is does not come under organic addition reaction. So these three are addition reaction, but the dehydration is the elimination reaction. So the answer is option D, dehydration. Okay. Next question. Which of the following is a tautomer of phenol? Now we all know that what is tautomerization, ketoenol tautomerization. Okay. This is phenol. Okay. Now here is one hydrogen. Okay, so in tautomerization, what will happen? This bond gets shifted to become a ketone, and this hydrogen gets shifted to this carbon atom. This one is the enol form. So from tautomerization, we will get the ketone form. That is, here is 2 hydrogen. Because this hydrogen gets shifted on this carbon atom, this bond gets shifted on this, so this will become double bond O, and this 2 double bonds. Okay, So we will get this keto form, which is option C. See, this represents the CH2 only, this carbon. So the answer is option D. Next question. Benzene reacts with n-propyl chloride in the presence of anhydrous AlCl3 to give predominantly. Now this word is important. Predominantly is what we have to find out the major product. Okay, remember this. Okay, so benzene with n-propyl chloride. Propyl, it means 3 carbon atom, CH3, CH2, CH2, Cl. This is n-propyl chloride in presence of anhydrous AlCl3, Lewis acid. So this reaction is Friedel-Crafts alkylation. So in this case, we will get two products. Whether this carbon atom gets attached to benzene or this carbon atom gets attached to benzene. So two products, that is benzene with n-propyl, CH2, CH2, CH3, and second one is benzene. When this carbon atom gets attached to this, then chlorine is attached to this carbon atom, and this CH2, CH3 is attached. Chlorine will be removed out. So instead of chlorine, what we will get? We will get CH3 with one hydrogen. So what is the name of this compound? This is n-propyl benzene, and this one is isopropyl benzene, because on second position, on iso position, there is one methyl group. So this is isopropyl benzene. Okay, now you can see in option n-propyl benzene bhi hai and isopropyl benzene bhi hai, but they are asking predominant product, that is the major product. So out of these two, this product isopropyl benzene is the major product. So the answer is option B, isopropyl benzene, which is also called as cumene. So kabhi options mein cumene option rahega, so you will get confused. Okay, so you have to remember this. Next question. Anti-addition of bromine to trans-2-butane yields what? Let's see the anti-addition. Trans-butane is this. One CH3 is on one side and another CH3 is on opposite side. Okay. So this is the trans-butane. When we add Br2, okay, Br2. So this Br with 3 lone pairs. So share pair electron will take place with these 2 carbon atoms and it will form the bromonium ion. How? See, this carbon atom gets singly bonded. Instead of this pi bond gets shared paired with this bromine. So we'll get this carbon, which will form a complex with the bromine. This carbon is with hydrogen, one methyl, and hydrogen. Okay, this bromine gets positively charged with 2 lone pair. So this is the bromonium ion. This one is the bromonium ion. Now we are having this bromine. This bond gets shifted. This electrons get shifted on this bromine, and this become Br minus, which will attack on opposite side. Okay. So after this, what will happen? One bromine gets attached to this carbon atom, and another bromine gets attached to this carbon atom. And substituents basically H3 and H. Okay. Okay. Now we will see the RS configuration. Okay. So when you find out the RS configuration of this, we will get, let's see, if we are talking about this carbon atom. Okay, so priority will goes to bromine. After that, this whole compound as a second, this methyl is on third, and this hydrogen is a fourth. Now 1 to 2, it means it is clockwise, but you can see the lowest priority, that is the hydrogen, is on solid wedge. Okay, so it means what? It is on solid wedge, it is nearer to the observer. So this carbon is having the configuration R but S. Okay, it means it is having S. Okay, like that, this carbon is R. So we are getting RS 2,3 dibromobutane. Okay, with this, we will get the another product, that is this carbon with this carbon, one bromine, another bromine in opposite manner. Okay, hydrogen, hydrogen, and one methyl. Okay, so when you look for RNS configuration of these two carbon atoms, these two are also RS. Okay, so first option is enantiomer and racemic mixture. Enantiomer कब होगा? When we are getting RR or SS. So ये option cancel. Only racemic mixture. When it will be possible when we are getting RR and SS, but we are getting RS, RS. Okay. So ये option be cancel. Only enantiomer. If we are getting RR, RR, SS, SS, so ये option be cancel. Only meso compound. Yes, because we are getting RS, RS. So the answer is option B. Next question. Organic compounds can be classified even based upon the functional group. Which of the following is not a functional group? Now, isocyano is what? Nitrile group. That is nitrogen triply bonded with carbon. This is isocyano. What is carbonyl? C double bond O C. Whether it is aldehyde or ketone. What is isocyanide? Isocyanide is the organic compound which contains the isocyano group. So we can't call isocyanide as a functional group, right? What is carboxyl? Carboxyl is the C double bond O OH. Okay, so out of these four, isocyanide is not a functional group. So the answer is option C. Okay, next question. Galactose and glucose are. First, we will see the structure of galactose and glucose. So Both are having same ring. Okay. This is glucose, galactose, then CH2OH, hydrogen on this carbon, hydrogen OH, OH hydrogen, OH, OH hydrogen. While in case of galactose, CH2OH, hydrogen, OH hydrogen, OH hydrogen, hydrogen OH, OH hydrogen. Now you can see only difference in configuration at this carbon atom. Here is H, here is OH, here is OH, here is H. And epimers are those which differ in configuration at only one stereogenic center. Okay, because of that, we can conclude galactose and glucose are epimers. So the answer is option. Now, what is N-mers? N-mers are the compounds which differ in configuration at acetal or heavy acetal carbon. These are N-mers. And while talking about the isomers are what? Same molecular formula but different structural formula. Okay, and ketose aldose isomers, these are compounds which differ in configuration at ketoses and aldoses position. Okay, so the answer of this question is option A, epimers. Now next question, read the following statements carefully. First statement, pyrrole and thiophene. This is pyrrole. Thiophene is 5-membered with sulfur. Okay, so pyrrole and thiophene undergo electrophilic aromatic substitution reaction much faster than the benzene. As you can see, pyrrole and thiophene both are having heteroatoms which can donate the electron density into the ring while resonance to stabilize the carbocations intermediate. Okay, so on basis of this, we can conclude that the pyrrole and thiophene undergo electrophilic aromatic substitution. If we are compared with the benzene, both of them are faster. So this statement is true. Second, pyrrole and thiophene undergo Diels reaction very fast. If we are comparing pyrrole and thiophene with furan, furan is having oxygen. Okay, so furan undergo Diels reaction very fastly because it has a 2 lone pairs, you can see. While pyrrole is having only one, thiophene is also having only one. Okay, so this statement is false. Third, pyrrole and thiophene undergo nucleophilic aromatic substitution reaction much faster than benzene. See, pyrrole and thiophene, both of them itself, they are nucleophile. So, no chance of nucleophilic aromatic substitution. Okay. So, this statement is also false. Fourth statement, pyrrole is a pi-excessive system while thiophene is a pi deficient system. Now, what is pi excessive? Pi excessive is a 5-membered heteroatom with electronegative heteroatom. So it will apply to thiophene, pyrrole, as well as furan, because all of these three are 5-membered heterocycles with the electronegative heteroatom, that is nitrogen, sulfur, and oxygen. Okay, which are electron rich as compared to benzene. But we can't say thiophene is a pi deficient system, because thiophene is also 5-membered ring with the electronegative atom, that is sulfur. Okay, so in pyrrole we are having nitrogen and in thiophene we are having sulfur. So nitrogen ka electronegativity is around 3 and sulfur ka electronegativity is around 2.5. So on the basis of electronegativity, we can say thiophene is less pi deficient, or it is less pi excessive than the pyrrole, but we can't say pyrrole is a pi excessive and thiophene is a pi deficient. Getting? So because of this, this statement is also false. So P is true, QRS is false. Which option? Option D. Okay. Next question. Which of the following can exhibit geometric isomerism? For geometric isomerism, alkene is necessary. In that, cis and trans. Okay, so we will see one by one. First is 1-pentene. Okay, CH3, CH, 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 CH2, CH2, CH2. This is 1-pentene, double bond on first carbon atom. You can see this carbon atom is attached with two same atom, that is hydrogen. How geometric isomerism is possible? So, ये option cancel. Second is 2-pentene. 2-pentene. Okay, so CH3, CH, CH, CH2, CH3. You can see this carbon atom is with hydrogen and ethyl. This carbon atom is with hydrogen and methyl. So see, carbon, double bond carbon, methyl, hydrogen, ethyl, hydrogen. So if we are talking about these two, this one is higher priority. If you're talking about this two, this one is having higher priority. So these two are on same side. It means that this is having cis geometric isomerism. So geometric isomerism is possible in case of 2-pentene. Let's see the third option, 2-methylpentene. Okay. 1, 2, 3, 4, 5. 2-methylpentene. CH2, 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 CH3. Okay, you can see this carbon atom is attached with two same atom, that is hydrogen. So geometric isomerism is not possible. So ye bhi option cancel. The next is 1-butane. 1, 2, 3, 4. 1-butane. Alkane. Geometric isomerism is only possible in alkene. So ye option B cancel. So the answer is option B, 2-pentene. Next, which of the following groups stabilizes the carbocation in electrophilic aromatic substitution? Now see, carbocation. is carbon with positive charge. To stabilize the positive charge, we have to add the nucleophile because nucleophile is having the negative charge. Okay, positive charge denotes what? Electron deficient. Negative charge denotes what? Electron sufficient. Okay, excess electron they are having. Okay, so for stabilization of carbocation, we will require nucleophile. Let's see. See, in first option, cyanide. So, cyanide is electrophile or nucleophile? It is nucleophile, right? So, this is nucleophile. Comma, sulfonic group is electrophile. So, one nucleophile, one electrophile, not possible. Second is carboxylic group. It is electrophilic, that is electrophile. Aldehyde, it is also electrophile, not possible. Next, amine, it is nucleophilic. Hydroxy, this is also nucleophilic. So both are nucleophilic. It means they can stabilize the carbocation. In fourth, one is trimethylamine, which is nucleophilic, but this one is electrophilic. So ये भी possible नहीं है. So the answer is option C, that is amine and hydroxyl group. Next question. In pi bonds, overlap region lies directly between the two nuclei. Now always remember this. Pi bond, how pi bond is formed? By overlapping. See, pi bond is by overlapping of two p orbitals. Okay, and this overlapping is a side-by-side fashion of electron density, right? Whereas sigma bond involves the overlap of single lobe of one orbital with a single lobe of another orbital. In this manner. Okay, so as I said, electron density, where electrons are present in nucleus. So they are talking between two nuclei and they are talking about pi bond only. It means that this statement is correct. So in pi bonds, overlap region lies directly between the two nuclei. Yes, the statement is true. Next question. In Karl-Ingold-Willox system of RS notation, following are rules used for naming enantiomers are true, except. So we have to find out the incorrect statement. Okay. First option is identify the chiral center. But obvious, firstly, we have to identify whether our compound contain chiral center or not. Okay, so chiral center is what? When carbon atom is attached with four different atoms or groups. Okay, so the statement is correct. Position the lower priority group away from you as if you were looking along C4 bond. Okay. So lowest priority group should be away. How we can identify in 2D structure? So if the lowest priority group is on dash wedge, it means it is away from observer. So dash wedge represents away. Okay. So if lowest priority group is on dash wedge, then it is okay. If it is not on dash wedge, so what we have to do? We have to rotate our compound. Okay. Next is, so this option is also, the statement is also correct. Then for other three groups, determine the direction of high to low priority, 1 to 2, 1 to 3, 1 to 2, and then 2 to 3. Okay. So this option is also correct. If we are taking the example of this, if this carbon atom is attached with, suppose, bromine, ethyl, hydrogen, and methyl, suppose. Okay, so first we have to check chiral center. So this carbon is attached with 4 different atoms and groups. It means this carbon is chiral. Okay. Second, position the lower priority group away from you as if you were looking along C4. So hydrogen is on dash wedge. It means what? It is away from the observer. Okay. Then for other 3 groups, determine the direction of high to low priority. Let's see. So bromine ka priority will be 1. After that, ethyl. After that, methyl. And after that, hydrogen. Okay. Then let's move from 1 to 2. So 1 to 2. It means it is anti-clockwise in this manner. Anti-clockwise. So remember this. If it is anti-clockwise, then it is S. S लिखते वक्त भी हम लोग कैसे जाते हैं? Anti-clockwise. Okay. If it is clockwise, then it is R. R लिखते वक्त हम लोग कैसे जाते हैं? Clockwise in this manner. Okay, but this statement tells what? If this clockwise, then it is S. But if this clockwise, then it should be R. It means that the incorrect statement is option D. Okay. Next question. Which of the following compound causes carbon-hydrogen bond with the lowest bond dissociation energy? Now, lowest energy, it means highly stable wala compound. Okay. If we will talk about toluene, now here we are talking about the dissociation energy. So we will talk in form of free radical stability. Okay, let's see. First is toluene. Toluene is what? Benzene with 1 CH3. Okay, by homolysis, what we will get? Carbon with free radical, hydrogen, hydrogen. But by hyperconjugation of this free radical, we will get free radical on this carbon atom. This carbon atom. So you can see this carbon atom is attached with 1, 2, and 3 carbon atom. So by hyperconjugation, we will get tertiary carbon free radicals. Okay, so in case of toluene, we are getting tertiary free radical and hyperconjugation is textbooks. Okay. Now we will see for benzene. So after homolysis, we will get free radical on this carbon atom. Okay, so this carbon atom is attached with 1 and 2. It means this is secondary free radical. So from benzene, we are getting secondary free radical. Now we will talk about N-pentane. 1, 2, 3, 4, and Now, the stability order of carbon free radical is tertiary, secondary, and then primary. Okay, so if we homolize the hydrogen from this carbon atom, we will get the primary carbon free radical. But if we remove hydrogen from this carbon atom, we will get the secondary free radical. So what we will do, I'll write the CH2 in this manner, carbon with one hydrogen and another. So after homolysis, I'll get this CH3, carbon, one hydrogen, one free radical with CH2, CH2 and CH3. So as you can see, this carbon atom is attached with two carbon atom. It means we are getting secondary free radical. Next is 2,2 dimethyl propyl. Okay, so 1, 2, 3, 2, 2. Okay, I'll write this CH3 in this one. Carbon with one hydrogen, another, and another. Okay. Now in this case, we will homolize hydrogen from this carbon only, because in this case there is no hydrogen to get the tertiary carbon free radical. Okay. So after homolysis, what we will get? CH3, C, CH3, CH3, CH2 with free radical. So in this case, we are getting primary free radical. You can see this carbon is attached with only one carbon. Now, on basis of the stability of free radical, that is tertiary, secondary, and primary, the most stable compound is our toluene, because after hyperconjugation, we are getting tertiary free radical. Okay, so the answer is option 2, toluene. Next is reaction of an halo-ester with an aldehyde or ketone in presence of this base, which gives epoxy carboxylic ester. That reaction is referred as. So we will see one by one. So Wilkes rearrangement में क्या होता है? Ketone, phenyl methyl ketone reacts with pyridine S8 with ammonium hydroxide. So we will get mixture of one. One is amide and the another one is acid. Okay, what they are saying, halo-ester. We are having ketone. Okay, so ये option cancel. Second is Bamford-Stevens reaction. Bamford-Stevens reaction में भी ethyl phenyl ketone लेते हैं. Sorry, propyl phenyl ketone. Reaction with tosyl hydrogen, that is TSNH2, in presence of sodium methoxide. So this is two-step reaction. First step में we will get diazo compound at the end we will get this alkene with nitrogen gas get evolved. Okay. They are saying halo-ester. We are having ketone. So this option also get cancelled. Now we will see Darzin's glycidic synthesis. In Darzin's glycidic synthesis, क्या होता है? Halo-ester. This is halo-ester with ketone, and reaction takes place in presence of NaNH2, this base. So what we will get? We will get this compound. Okay, which is nothing but the epoxide with carboxylic. Okay, so epoxide carboxylic ester. Halo-ester, aldehyde or ketone in presence of base like this, we are getting epoxy carboxylic ester, and the end product is this. This ketone in presence of NaNH2. Okay, so the answer is Darzin's glycidic synthesis. What is Bayer-Villiger rearrangement? Bayer-Villiger rearrangement क्या होता है? One ketone, if we are taking this, reacts with peroxy acid, any peroxy acid. What will happen? This acid will be removed out and we will get ester. Here is oxygen. We will get ester. Okay, so ये भी option. So the answer is option C, Darzin's glycidic synthesis. Next is, in the Dumas method, the nitrogen present in organic compound gets converted to. Okay. Now, what is Dumas method? Dumas method is a quantitative method for the determination of nitrogen. Whether the nitrogen is present or not in our compound, we can check with the Dumas method. How? So in this method, what happens? We take mass of our organic compound with copper oxide. After heating in presence of carbon dioxide, we will get carbon dioxide with water and nitrogen gases evolved out. Okay. So first is sodium cyanide, जो कि reaction में है ही नहीं. Gaseous ammonia, no. Dinitrogen gas, N2 gas is nothing but the dinitrogen gas. So the answer is option C, dinitrogen gas. Next question. Which of the following is the correct representation to relate the two resonating Kekule structure of benzene? Now this arrow represents the straightforward reaction. Okay. Reaction. While this represents for equivalency. Okay. This arrow is for resonance. This arrow is for reversible reaction. Okay. So out of all these four, this arrow relates the two resonating Kekule structure of benzene in this manner. This having this resonating structure. So the answer is option C. Okay. Thanks to all of you for patiently hearing me. Okay. Thank you so much.